this lesson, we're going to look at trees. A tree is the second most important data structure in computing, next to lists. Trees are very useful for organizing information, for efficiently being able to do kinds of computations, for looking up, and for doing all kinds of calculations, maintaining certain properties. They're, in fact, ubiquitous. Trees are also a good example of goal-oriented programming, which is a generalization of invariant programming, because many tree data structures are based on a global property, a property of the whole tree that must be maintained during the calculation, and this drives the calculation forward. So in this lesson, we will define what is a tree, and then we will do some interesting computations with it. We'll use them to store and look up information. We define a particular kind of tree called an ordered binary tree, and we'll define algorithms to add information, look up information, and to remove information from ordered binary trees. So a tree is a recursive data structure. It's either an empty tree, which is called a leaf, or there's an element here of type T and a set of subtrees. So the trees that are underneath the main tree, which is called the root node, are called subtrees. So this is kind of a bifurcating structure. We start with a single root node. We have a number of subtrees, and each subtree has its own root node and subtrees, and so on until we reach all the leaves. So here's an example of a tree. This is an example of a ternary tree, a tree where each non-leaf node has 3 subtrees. So here, for example, the main root node has a value 100. The leftmost subtree has a value of 10, and it has just leaves, has its own subtrees. The middle subtree here has a root with a value of 20, and itself has only leaves. And there is no rightmost subtree, there is just a leaf. So this is a typical example of a tree. We can compare trees to lists and see how they generalize lists. So both trees and lists are recursive data structures. They're both either empty, which are called leaves, or elements and a set of trees or sublists. The trick about lists is that there's only a single sublist. A list is a linear structure, whereas a tree is a branching structure. But other than that, the recursive form of both is the same.